Yeah. All right, so 113.
Can I leave it the whole day?
Sure. 113 is called function model selection and articulation assumption. Okay, a bunch of fancy words. For function model selection is what's the best function to determine this or to use for this data, quadratic, cubic, that kind of thing. Which that part you've done before. We just named it by the degree instead of the model. Okay, and then articulation assumption is here's some real world scenarios. Let's talk about what the kind of restriction would be on their domain, their range, and what kind of model would be the best to use to describe these, okay? So it literally starts with what we already know, that if a function should be, or if data, okay, is given to you, and the first difference on that data is the same, then that data is best represented by linear model. If the second difference is the same, then quadratic should work, or would be better. And if the third difference is the same, then it would be cubic. So we start with just that. Determine the appropriate model for the data and explain why it models the data. So first thing you got to make sure is that your x interval is consistent. So in that first x interval, I get -3 to -2 to -1, and it is consistent, like going up by ones. If that's the case, I don't even have to put an over, right? I could just do 5 minus 15, -1 minus 5, -3 minus a -1, -1 minus a -3, and 5 minus a -1. So I get -10, -6, -2, +2, +6. Already I would rule out what? Linear, because otherwise that would have to be the same, right? Good. Now I go to second difference. So I'm worrying about the difference here. -6 minus a -10. -2 minus a -6. 2 minus a -2. And 6 minus 2. And I get 4, 4, 4, 4. Which means the best kind of model for this would be what? Quadratic. And you could say second difference is constant or the same. Yeah. So the next one. Well, it has to be the same kind of interval. It will be the same. It just maybe won't be 1. So for this one, the first difference, we're going to do -15 minus a -18 over -6 minus a -8. So we want to find our rate of change. Children, behave. And as long as it's consistent, it's fine, right? If it's inconsistent, then I can't use this kind of data to figure that out. So this would be 3 over 2. Did I do that right? Yep. This would be 3 over -4. This would be 3 over 2. This would be 3 over 2. This should be a 6. I can't read my own handwriting. This is a 6. So this is 2. Okay. And this is 3 over 2. So this time, what's true about that first difference? These are the same. Good. So this would be linear. First difference is constant. Yeah.
What is this called again?
This is your rate of change.
So I put over the 6 and 8.
Yeah, I'm doing change in y over change in x, change in y over change in x. Yep. Example 2 says a bottle rocket is set up on a picnic table. When the firework detonates, it will shoot straight up and come back down. The height of the rocket is modeled by h of t, and it gives you the function for h of t, where t stands for time in seconds, and h is the height of the rocket in feet. So first of all, I've got a rocket on a picnic table, right? So if it's a picnic table, it's going to shoot up and it's going to come back down, okay? That kind of shape should be quadratic, right? And it should be a quadratic that points down, which is consistent with our -15t squared. So A says find h of 1, and what does it mean in this context? Let's pretend we didn't have a calculator because this could be done without. How would you find h of 1? Plug in 1. Oh, I'd literally just plug in 1. So I'd get negative 15 plus 64. So you get minus 15. 49, right? Yeah. Okay. What does it mean in this context? So now we're talking about the actual real world scenario, and we have to talk about the input and the output. So what does the 1 represent in this model? Time in seconds. Good, I heard both. And what does the 49 represent? The height of what? A rocket in feet. Good. So all of that has to come together. So after 1 second, the rocket reaches, doesn't have to be exactly this, but reaches a height of 49 feet. So I have to give the input and the unit on the input. I have to give the output and the unit on the output. We good so far? Okay, so now go to B. What's the restricted domain? Is there a restricted domain on a parabola?
No, yeah.
Without a real world context, any parabola, is there a restriction?
No.
There's no restriction on a parabola, right?
That's right.
But this is a real world situation, yes?
Yeah.
So should we restrict our parabola? Yes. Okay, it can't go left of the vertical axis, right? Because it's not going back in time. So wherever it starts on my actual table, for example, would be the first X, right? Can't go backwards in time. And then where's the furthest X? What does it look like on your graph? What do we call the point where the furthest X would be? If it's a rocket, does it go underground?
No.
No. So it's, well, like a real, actual bad rocket, sure. But this bottle rocket, no. Okay, it's going to stop here, right? So how would I know what this is? It's the x-intercept or the 0. Does that make sense? Yes? Without a calculator, how would I find my first x I know. How would I find the second one? I would plug in 0 for y. This, we would have a calculator on because these are nasty numbers, okay? But if it was, you could do the quadratic formula if you didn't have a calculator, right? We're going to do it for this one. So we know our furthest point left is where it starts and time is 0. So 0 is going to be my furthest. I don't want to go back in time. So 0 is going to be the start of the time. And then I want to find the x coordinate point where it hits the x-axis. So I'm going to graph it. I'm going to go negative 15 t to the second, which is x to the second, plus 62 t plus 2. Okay.
Currently does not get it.
All right, so your x, we said it would start at 0, even though it might go back before my y-axis. We're saying that time doesn't make sense if it's negative. So we're starting at 0 and we're stopping where the rocket hits the ground, where if you look on the graph, you'll see my x value there is 4.165. So my restricted domain is going to go from 0 to 4.165. Okay? It can include 0 because it has a starting spot, and it can include 4.165 because that's where it hits the ground. You could also say 0 is less than or equal to x, which is less than or equal to 4.165. Second part, or third part on this one, says what's the restricted range, okay? Obviously on my parent function, that's a parabola, those arrows point down, and technically the range is going to go to negative infinity. But we said this rocket is stopping at our x-axis, right? So what's the lowest y? 0. And what's the highest y? It's the y coordinate of my max, right? So I'm going to zoom out. Not for range bottom to top. So I'm going to zoom out again. That's why I should have done it on Desmos, because you would have done this faster, but it's fine. Okay, I'm going to zoom out again. I just want to make sure I catch the top of the graph. So I'm going to go second trace. Second trace. I'm going to go to my max. I got to go left of it. I got to go right of it. And I got to hit enter, and it's going to bring you to your max. The x coordinate is 2.067. And the y is 66.067. So my range goes from 66 point, I didn't make this up. This is the notes from last year. Okay, that would be my restricted range, 0 less than or equal to y, which is less than or equal to 66.067. I didn't actually. If you look back on last year's video, before it was a thing, it's the same numbers. Questions on that? No. Okay, D says, what's the average rate of change for the interval of 1 to 3? How do we find this? Oh.
Sorry, are you doing the left one and the right one? Are they the same thing? You're just doing them both ways?
Correct. Yep, you could have either answer. Yep. You're welcome. All right, average rate of change. How do I find? I'm going to either plug in each or use the calculator, but I'm going to do f of 3. Actually, my variable is h this time. H of 3 minus h of 1 over 3 minus 1. Or, calculator, go back to that home screen. Alpha, y equals, gives me my fraction. Alpha, trace, minus 1 over 3 minus 1, which is 2. And so my rate of change is 2 feet per second. Questions? Should have moved you today. All right, this is a piecewise function, okay? The good news is you don't really have to build it, but you have to understand it. So it says the graph of F below shows the price of a concert ticket during the first 10 hours that the tickets go on sale. The cost of a ticket starts at $80 for the first 2 hours and then increases each hour. So if you're reading this graph, from 0 to 2 hours, your dollar price is 80. Then from 2 to 3, it jumps up $10 and it's 90. Then from 3 to 4, it jumps up and it goes to 100. Okay, so that's what each of these represent. What is the solid dot and open dot indicate?
Whether it's included or not.
Good. So at 2 hours, what is your price? 90. Does that make sense? Because that's the solid dot.
Yes.
Okay. So also, what would happen if these were both solid dots? What's wrong with that?
Oh, that's the line test.
It would fail your vertical line test. It would not be a function. Does that make sense? Okay. Good job. All right. So it says, what's the domain in this context? So as I move from left to right, what's the first x? 0. And is there an x for every value from left to right until it hits the end? Yes, because there's an open dot, but there's a solid dot on top of it that stacks. Does that make sense? Okay, so my domain in this context is from 0 to 10. Do they both get brackets? This is like a solid dot, so the 0 gets a bracket, but what about the 10?
No.
It would get a parentheses. So 0 is less than or equal to x, which is less than 10, okay? Because there's an open dot at 10.
May I ask, how is it going to be shown on the test?
I haven't gone that far. If it's multiple choice, you'll know. If it's open-ended, I'd take either one. Yeah. All right, B, what's the range in this context? So now we're going bottom to top, right? What's the lowest range? What's the lowest y? 80. Is there a y for every value from that to the top? No, there's gaps, right? So the way we list this is literally every y value. So it goes 80, then 90, then 100, then 110. We're going all the way up to 160, 120, 130, yeah, 140, 150, and 160. And you literally just list them all. Nico.
For the way that you put the...
All right, C says find f of 7.5, and what does it mean in this context? So 7.5 would be here, right? And we go to the y value, and what's the y value at 7.5? 140. And what does that mean in this context?
I'm not sure.
Somebody started it. Was that you, Jocelyn? Go. Good. After 7.5 hours, the ticket sales or ticket cost is $140.